All right, my friends, you probably have recognized by my voice that I am not Miss Turner, but I'm going to do my best to try to help us discover some things about rectangular prisms. You probably recognize this shape from last year. In sixth grade, you should have had an opportunity to work on volume of a rectangular prism. In front of me, I have a rectangular prism as well. This is a box in which I purchased some Crayola markers. You'll notice something about the box. It has top and bottom, has a back side and a front side, and it has this left side and this right side. That's a total of 6 faces or 6 surfaces. And a rectangular prism has 6 surfaces. Now, if we took this shape, this 3-dimensional object, and if we cut along the edges and we unwrapped it, what we have is something that you see here on the page. So a rectangular prism has 6 faces or 6 surfaces. And a face is any flat surface on the prism. So our shape, the rectangular prism, has 6 faces. A face is any flat surface on the prism. And when a 3-dimensional object is unfolded into a 2-dimensional image, we call that a net, like the one below. We call that a net. And for surface area, it might seem obvious, but what we're going to do is we're going to calculate the area of all the surfaces. And so as you notice, we said that our box had 6 faces, and so you'll notice as this net has been unfolded, it also has 6 different pieces to it. So if we think of this box here unfolded here, we would have a top and the front side, and the bottom and the back side, and these out here would be the 2 edges. Now we've shaded this and this here, and so we're going to talk about what that is in a minute, but the first thing we want to do is we want to just remember how to solve for area of a rectangle. Pretty easy. So we want to find the area of all 6 of these, and we calculate them, and so for total surface area, what we're going to do is we're just going to calculate all 6 surfaces, and we're going to add them together. If you'll notice the measurements of these pieces of the net, these arrows will tell you that the length of this edge and this edge, they're both 2.5 inches. And if they're 2.5 inches here and here, they're also going to be 2.5 on the other side. And for some students, it might be helpful to them if you go ahead and label the other side also. Sometimes it's helpful to label all of the edges, that way we're not making a mistake on which value it's supposed to be, which measurement. So if these 2 are 2.5 inches here and here, then that means here and here are also going to be 2.5 inches. Because this surface here, this was the top part, and this surface here would have been the bottom part of the prism. Those are, not only are they parallel to each other, but they are congruent. They're the same size. So if these edges are from this top part, then this edge is going to be congruent. They're going to be the same size. And so if we have this edge right here being 3.5 inches on this section all the way across here, then from here to here is 3.5. That means this bottom piece as well will also be 3.5 inches, which is kind of nice because now we're just really working with 3 different numbers. And as you see, from this left side to this right side is 7.5 inches. That means every piece down the middle is also that distance across. So this is 7.5 inches. This is also here 7.5 inches. That means from here to here is 7.5, and you guessed it, the top is also 7.5 inches across. Now the best plan, I think, for surface area is to find the area of one rectangle and write that area inside that shape. So let's do that. So let's take this top one here, and it's 7.5 by 2.5, and so we're going to multiply that together. 7 5/10 times 2 5/10. And we'll multiply that out, and that's 5 times 5 being 25. 5 times 7, 35, plus the 2 is 37, my placeholder. And then 2 times 5 is 10, the 0 goes down, the 1 goes up. 2 times 7 is 14, plus my 1 is 15. And when I add that, that's going to be 1875, and we recognize that when we're multiplying, we have to finish our product with the correct decimal place. And so in our problem, we had 2 decimal places, 2 numbers to the right of the decimal places here, so we have 1, 2 to the right in the solution. And so that means we found the area of this rectangle to be 1875, and that would be, this being area, this is square inches. But to put that inside, we're just going to put 1875 and circle that. That means we know that one's done. Now, if we remember that the opposite surfaces, the opposite faces are congruent, that means if this is the top of the box, that means the bottom of the box is going to be the same size. Go back to my Crayola box for just a moment. If you'll notice from here to here, this top of this box is this shape, and so then if I flipped it over to the opposite side, you're going to notice that this side as well is parallel to the bottom, and now it is also congruent. These 2 sides, these 2 faces are congruent. And that means in our net, when we've unfolded it, that means in our net is you're going to have 2 faces that are, these 2 faces are congruent. So if this is 1875, then this one here is also 1875. These 2 being opposite sides, and they're going to be congruent. They're opposite sides of the prism. So we have 2 of them so far. Now let's work this larger shape in the middle, and we recognize that it is 7.5 inches this direction, this wide, and it's going to be 3.5 from top to bottom here. So we'll need to calculate that on this right side, and I'll try to keep my arm out of the way so you can see it. So 7.5 times 3.5, 5 times 5, 25, 5 down, 2 up. 5 times 7, 35, plus 2 is 37, and I'm finished with that too. My placeholder goes there. 3 times 5 is 15, the 5 goes down and the 1 goes up. 3 times 7, 21 plus the 1 is 22. And we add. Two numbers to the right of the decimal places in the question, and so my product also has 2 places to the right of the decimal, 1 and 2. So I'm going to take this is going to be inches squared, and what am I going to do with that? Well, I'm going to place this number into the rectangles.